Hey everyone, good morning. Let's get started. So, the first session for the today, we have visual data storytelling with Blender and Python. We have two amazing speakers, Neeraj Pandey and Manoj Pandey. So, please give them a big round of applause. Let's get started.
All right, welcome everyone. So this is a pretty looking map that I just created this morning. This is where we are in Pittsburgh, from one of the sponsors. They had an open source tool. So today we're going to talk about visual data storytelling. Anybody here, like, just quick show of hands, like how many people have already like created some graphics or some visuals ever? Pretty much everyone, right? So I think we have seen some form of visuals or graphics everywhere around ourselves. Think of those cool infographics and animated charts you see online and explaining climate change or showcasing sports trends. So usually they're often created with a variety of tools like Illustrator for some graphics, or JavaScript for some interactivity, or using some sort of like Blender for like 3D animation. So as we are at PyCon, Python steps in as a very powerful language that we can use for data analysis behind the scenes. So we're going to talk about some of the tools we can leverage using Python. And today we're going to look specifically into animations in Matplotlib. And there's a very small community of tool called Manim. We're going to discuss that. We're going to go and talk about Blender and talk about the Python API and show you a bunch of 2D and 3D graphics, and hopefully a lot of different graphs to keep you motivated. So these are all like static plots. There's a bunch of them. I think you probably have seen some of the other ones. They offer a valuable snapshot of your data at a specific point. So sometimes we need animation or like a 3D view of the graph to see like a bigger picture. If you want to see how the data evolves with time, we need a bit more interactivity. We need some more visuals. So animations come into the play. They are the visual elements that enable you to breathe life into these data sets. And we can find some underlying trends and patterns. Quick show of hands. Do you know about Matplotlib? OK. So I'm not surprised. We're at a Python conference. I think Matplotlib is a very important library in the Python data science ecosystem. And it serves as the bedrock for all the data visualization in Python. I think it started in 2003-ish, so it's like more than 20 years. So these are all from Matplotlib. It excels at generating various static charts and graphs, line plots showing trends, scatter plots, revealing relationships between data points, or bar charts for comparisons. So it's a pretty diverse tool. Also, it's very seamless with NumPy. So if you have a lot of like numerical data stored in NumPy arrays, you can directly move it to Matplotlib. So these are some examples, and you might even try some of this. If you see some memes on XKCD, they recently put it inside the library with a specific font called Humor Sans. So today we're going to specifically focus on harnessing its animation capabilities through something called the Func animation and the Matplotlib animation library, which basically means how to build animations like this. Should work actually automatically. So some basic elements. These are all from the Matplotlib gallery, by the way. So if you want to like take a look, you can go back later and find all of these on the internet. I have to tell that Matplotlib itself is not the animation library. It's not the animation engine. So I'm going to give you like a simplified view, like what happens like behind the scenes. So Matplotlib or MPL, they have something called as an artist. So they build these artist objects, which basically goes to a rendering engine. The rendering engine could be something like FFmpeg or anything. There are like tons of them. So it supports tons of backends, which you can utilize to produce those the final renders. So essentially, Matplotlib focuses on what the animation looks like at each step, while external libraries, they handle the technical aspects of creating the final animation. So you define the frames. Your code creates the logic for each frame of the animation, updating data or plot elements. And then these Matplotlib artists are generated. So Matplotlib uses an artist object, which are lines and markers 2D points to represent visual elements, and you manipulate these objects within your animation function. There are like 2 types of animation classes. We'll get into this. And finally, it goes to the external libraries. So Matplotlib animation module works with libraries like FFmpeg or ImageMagick to handle the heavy lifting. And these libraries basically render each frame you created with Matplotlib, and they stitch the frames together for like a smooth playback. And you can do a lot of things, like how the playback is going to be like changing like different components of it. And also it encodes the animation into a final movie, so you have like let's say an MP4 or like a GIF at the end. Okay, so now we're going to go slowly into it. So this is Matplotlib animation. As I said, it comprises of like 2 subclasses, which comes from the animation module. So we have like 2 animation classes called the func animation. It takes like some sort of like a function, and the artist animation, which takes like some fixed artist. So in this presentation, we're going to mostly explore how to use like func animation because it's more flexible. And it's very powerful to create like dynamic plots that can communicate like the trends and patterns in your data. So func animation is like very function based. It takes like a function, and you are updating the plot like one by one or even in a loop. But on the other side, like the artist animation is more like a fixed, like where there's some like static trend that you want to convey, and it just like takes that. I'm going to go a little bit more. We'll keep the artist animation aside and deep dive into how exactly it works. I hope it's visible, like the code. So this is like the fundamental of how you generate animations in Matplotlib. You can use the artist animation as well, but also we're going to take an example of using func animation and show like what's the output in the next slide. So in the beginning, yes, you import, you define your plots and your axes. Matplotlib apparently has like a nice interactive like a graph on their docs, which tells you exactly like how to figure out the axes. So take a look after the presentation. The second step is the initialization and update method. You basically set up your data and you initialize the graph, or the plot in this case. And once this is done, so right now here we're taking some equation. You can see like y is like sine and a cos equation. Here is just like a sine data actually. So we animate it at the end and save it as an image, which I'm going to show you right here. And it basically generates like a sine wave. This is a very basic example, by the way, and you can change those equations depending on like whatever mathematical thing you are trying to utilize. But also, so instead of plotting lines individually using the plot method, like there's something called as collections inside of Matplotlib. One of the important collections is the line collection, which allows you to define multiple line segments, and it renders all of them together at the end. So for example, this is a combination of a sine and a cosine wave, and it leverages the optimized rendering techniques for better performance that you can also like specify in your method. So this is basically making the individual segments and then stitching them all together, and finally you have like something which moves basically. It looks like it's moving at the end. By the way, all the codes in this slide, there's like a Jupyter notebook that we have prepared, because although these examples are like very small, like making the data set, making the data behind it, it's a bunch of code, and we don't want to like put it here, but it's at the end of the presentation. You can take a look, and you can also run those examples yourself. These are some more examples. Should work. It's like a quiver plot with like vectors like moving in different direction. So it represents vectors at specific points on the graph. It works now? Yes. And the arrows, tail points at the vector's origin, x and y, and the head indicates the direction and the magnitude of the vector. It looks pretty nice when the video works. Okay, it works now. There are like some other examples. Those of you working with probability or statistics, you might have used like confusion matrices. So you can make this one of this matrix in 2D as well as in 3D. So this is basically like a table which summarizes the performance of, let's say, a classification model. And Matplotlib also excels at creating heat maps. It also adds up other libraries like seaborn and bokeh, which you can like use on top of it for visualizing these kind of matrices. And this is the same example, but in 3D. So you can also utilize Matplotlib to generate like 3D visuals. This also works when the video works, pretty nice. So 3D visualizations might not be the most intuitive way of representing these kind of matrices, especially when there are tons of classes involved. But you just have to consider the trade-off between the dimensionality and the clarity. Finally, I think there's like some more examples. Somehow these videos are not working because of the internet, but this is an example for airflow simulation. So if you're, it's like a contour plot. So if you're interested in visualizing, let's say, a specific airflow property like pressure or speed, you can create a contour plot on the surface, and you can use the surface data also with X and Y as a grid, and the airflow property, the values for doing these contours. You can also make more complex surface data. You can explore libraries which also connect directly with Matplotlib, like scikit, and they also have more and more like 3D visualization capabilities. So yeah, if you have, let's say, time-dependent airflow data, you can use these animation techniques which come right off from Matplotlib to visualize the flow evolution. So now we're going to do a little segue into another component that we're going to show you, and I think Neeraj is going to tell you more about it.
Perfect. So, lots of animations we saw. Now let's talk about Manim. So, how many of you have seen mathematical like videos, animations on YouTube, which just like creates these graphs? Maybe you guys have seen 3 Blue, 1 Brown channel. So we're going to be talking about Manim, which is basically stands for Mathematical Animations Engine. And it's basically developed for precise mathematical and graphical or algorithms to portray on your graph. But what makes Manim more special is first, it has like too much of flexibility. You can make exactly what you're looking for in terms of mathematical animations. Second, it uses vector graphics, which means like doesn't matter what, your final video is going to be crystal clear. And if you guys have used LaTeX or you make like papers or mathematical equations in LaTeX, you can directly integrate those equations and Manin will create those videos for you. So before we see how Manim exactly works, like some examples with Manim, we should know like how Manim exactly working behind the scenes. So it operates by like initially writing a Python code, which then sends that information to a render engine, which could be for 2D, it's Cairo. Basically, it uses PyCairo, which is an abstraction model on Cairo. Or it uses WebGL if you're working with 3D animations. So the first step is a scene generation, like what exactly we want to work with. So we write some Python code. We use some Manin objects, M objects, and then the objects are added to the screen, and then we use animations like create, transform, and all those things. So that's exactly what you guys have to do when you're working with Manim. And once you wrote this Python code is sent to the rendering engine called Cairo, as we discussed. So you can imagine like your Manim script as a movie script. Like it tells you the story, like what exactly is it, but doesn't show you anything. So what Manim is doing, it uses Cairo to act like we can say a movie director. Like Cairo takes your script, what all instructions you're just like placing using the M objects, and creates those individual images like single fragments and snapshots, and sends it further to FMPEG. So what Cairo does is like it uses its own artistic skills, we can say, to translate those instructions into single frames of artworks or your animations. And just like a video clip, it has like multiple frames, let's say 15, 20 frames per second. Cairo does the same thing. It just like breaks those things into different frames and sends it to FMPEG, and which then glues all those frames all together and creates a video out of it. So it's basically creating like a illusion that everything is smooth, but if you just like break it into piece by piece, it's going to be just like single images, like combined into a single video. So in short, we can say Manim uses Cairo to create those individual images based on the animation inputs, and FmpEg takes these images and assembles them into a final video you are looking for. So the building blocks, like before we see any live example, we should know like what are the building blocks of Manim. So the first one is a text M object. So it basically lets you write or create some messages on your scene. Then we have lines and shapes. So these are different logo pieces, maybe lines for planes, circles and squares, and all these shapes you can just like plot on your canvas. Then we have those two important things, which is called M objects and VM objects. So M objects is basically a class on which serves as the building blocks for your like the Manim animations. And each class is derived from this animation, like the squares, these lines, the circles, and everything. And then they are just like displayed on the screen. What's the next one? So if you have to see like a small like example of how things actually work, it's like we always define a class. Like here we define basic object scene that inherits the scene. So this is like creating a blueprint for your animation. And the scene, you can say it's a class where you set up those animations for all your elements. And the scene class it's more like your Lego building board. Like it sets the stage for your entire animation. Without this, nothing will work. And everything has to be done inside this construct function you're just creating. And we're doing like three things over here. We're just like creating a text. We're just saying hello Python, adding some font size, and asking it to go to the top of the canvas. Then we adding a line object. We're asking it to create a line from the left to the right of the scene and add some color to it. Then we have like a circle object and all those things. And eventually what we are doing is like we're grouping all those them together and asking it to push it a little down. And then the self.play, this is basically how your animations are generated. So once all those things have been done by Cairo, this actually generates your animations or the illusion of animation, where write is basically giving you that illusion of like writing is happening. Creating of line is like a line has been created. It's basically points by points. And then you have like a draw, border, then fill. It just like draws it, fill, and creates a stroke out of it. Yeah, so those were the very basic examples. Now we can see like the same wave example we saw in Matplotlib. We can also like mimic those things. So here, this example is basically using a sine plus cosine function, and which combines all together to maybe mimic a wave of like double frequency. So this results in like a more complex wave pattern than just like a single thing, and serves as an intersection between two components. And here the range we are just like setting is like minus 2 pi or 2 pi. So this is how you do it. I think there's like a typo over here. Ignore that. And if we go into the actual functioning of this code, we can see like this wave function first defines the wave function class. And then it sets all those axes, coordinate system specified between a range of minus 2 pi to pi. And then the axes are labeled between time and amplitude. I'm not sure if there's no video, okay. And once that is done, all the scene creation has been done. We actually go into defining the function which we are going to use. So we just like say, oh, this is the wave function we're going to use, which is going to be a sine plus cosine wave. And it's plotted between the defined range, which we already defined. And then we initialize that setup by saying, this is going to be our VM object. So why are we using our VM objects and not an Manim object? M object is like whenever there's like a vector involved into Manim, we just like change the parent class from M object to V object. And yeah, that's pretty much it. We just like set those points, add some colors, and goes to actually generating the thing. So we added the components, we created the axis, we created the labels. Now we're drawing the actual wave, which is using the update from alpha func. This is a function derived by Manim itself, and it's used to generate that drawing onto the graph, and then adds the smooth animation you're seeing. And then we add something like a runtime, which says like, oh, we want to slow down it or fast the animations. And we just also add a wait time, which is like a final time it takes before it ends the animation. And eventually, we again, like, we see something like a smooth wave going from -2 pi to pi. We can also work with a lot of coordinate systems. We can say, we can add some grids, we can add some labels again. Like here we can see a red dot is just like originating and it's labeled and it's going up and down. And all these horizontal and vertical lines are dynamically created. So all of those things are like pretty much possible in just like a few lines of code in Manim. And we can also work with like linear transformations. So let's, oh, okay, so this shows eventually a linear transformation by, it starts with a matrix. We define a matrix, which is like a 1, 3, comma 3, comma 4. And then we add some geometrical shapes like triangle, rectangle, square, circle, which eventually shows you the transformation, how the matrix is being transformed. So all of those things are possible in Manim, and you can always like do more complex stuff and create those animations. One more thing before we go to Blender is we can always combine Manim with Matplotlib. We have seen like how Matplotlib has been pretty good for creating charts and datas, and Manim is like a perfect for creating engaging animations. So we can integrate both of them. We can create those graphs and visualizations we need with Matplotlib, and then we can create those high quality videos with Manim. So if you see, this is like a very basic example of, we created a bar plot in Matplotlib and just like added it to your Manim code for the animations. We're doing nothing complex. We just had the same thing. We called Matplotlib function to plot the graphs. We added 3 bars over there. We styled it a bit. We added some colors. We saved the image from Matplotlib as bar chart, and we just like injected that same image into Manim using the iImage object. So that's another third object which you use instead of object whenever you're working with images, and then you just like loop back the image back and forth. So that's how you can create your animations. So if you go a little bit step forward, you can see like, you might have seen like there's a lot of data which is just changing. So you can also use that information of like data being changing over time, and you can just like plot it into Manim, and Manim will just like create this animation of like how the data is being changing over a period of time. So yeah, that's pretty much it on how Manim can be used for creating 3D visuals, specifically when it comes to mathematical equations or animations. The last thing we're gonna quickly go through is Blender. So for those who don't know, Blender is like a 3D animation studio. You can assume that. And you can create all sorts of characters, visualizations, animations, whatnot. But like when you don't want to manually do things, you don't know like how exactly you're gonna tell the Blender how to move, what to make and all. So in short, we uses Python code to control Blender like a puppeteer, and you tell what exactly you want the project to do, how you want things to appear, disappear, and all those things. And Blender has like vast majority of use cases. You can create some 3D objects, you can animate scenes, you can use your Excel data, CSV data, use pandas directly into your Python API using BPy, and create those Blender animations. So before we actually see the last few examples, there are 3 major components of Blender API, which is one is the scene management. Scene management is just like setting up the stage, just like the actors on the stage on a theater show, and they're all the objects in your Blender scene. And once that is being done, we can create those scenes by simply calling bpy.data.scenes, and that will just like set your scene in Blender. And we can also tweak the lightings, like how bright or dramatic you want the scene to look like, where exactly the light should come into the sort of scene, what should be the angle for the people to view that animation and all those things. So it's pretty straightforward. Like we can set up the camera over here. We can call like bpy context and scenes.camera. We can change the location. We can use the rotation underscore Euler function to add some angles on how exactly the camera should look like. And similarly, we can add some lights. We can add some intensity on the light, like how intense the light should be. And the third thing in scene management is switch. We talked like how we can create new scenes in Blender, but what if we have already a few scenes created into our main screen, and we want to switch between them. So Blender also API provides this switching capability where we can directly switch between one scene to the other. We can think of like this functionality as a stage manager or something, who can just like quickly switch between the screens prepared. And the second thing is like all object manipulation. We can add objects. We can delete those objects simply by calling bpyops.object.delete. We can also direct these actors because you need to guide your Blender animations. It doesn't work like Manim. You can't just like say, oh, just like plot this thing. You have to specify every single move, where exactly the object should rotate, how it should scale, how it should shrink, and all these things. And here we see like on the right hand side there's a small cube which was initially just like the basic cube which was set up in Blender, and then we added the rotation Euler and just like rotated it like 45 degrees, and we also scaled it just like double the height of the cube. And then we can also handle the data. Like we have so many inbuilt data objects like meshes, curves, armatures, which is like skeletons which we use. We can use all those things directly into our Blender API and just like add it to the screen. Here you can see like we are moving the vortex like by a little 0.5x on the x-axis, so the cube eventually shrinks, and we can change the mesh, which also creates like 3D like textures onto your plots. And this is like a basic cube. We are doing something like we are first deselecting everything from the screen so that like we have a clean state to work with. Then we are calling a create cube function, which defines, which takes a new location for where exactly you want to add those cubes. And the cube is being used to add those operations. Then we are trying to use the bevel modifiers to smooth out those cubes, add some smooth out textures on top of it. So that's why we're using the object shade smooth. And then eventually we're calling that function, and the loop runs 3 times and creates those 3 random cubes on your screen. And yeah, so as we saw like a lot of confusion matrix in Matplotlib, we can similarly mimic the same thing in Blender, where you can have some data and you can just like directly plot it into your Blender and create those confusion matrix. And what we are basically doing is like we're adding a confusion matrix which is NumPy arrays. We are then normalizing the value so that like the height of the cube is relatively fitting the scene properly. Then we have the cube creation, just like the last example. We are just like calling the cube function, adding some bevel modifiers to smooth out the cubes, and eventually we have those small cubes happening. We then add the animation functions, which adds the functionality to make the cubes growing from 0 to a scalable position, like how much scaling you have added. And a text function, a create text function, which is adding those labels to your chart. Then we have the final function where we are just like creating those grid with using the NumPy array and setting up the camera functions and lighting, like where exactly the light should come into the play, because we are also seeing like when the cube is growing, it has some shadows, so camera angles, lights, and all those things matter a lot. And yeah, that's pretty much it about how we can create those visuals in Blender. And one last example is like we can also create something like a line graph using Excel data in your Blender API or the Blender console. Yeah, thank you. That's pretty much it. And I think Manoj will take over and give you some information on the resources.
Yeah, thanks a lot, everyone, for listening. This is, it was like a lot of information in the presentation, and initially we were thinking to have like a just presentation for Blender, but then we realized we should give some information about the graphics and how you do like things from scratch. There are like a bunch of resources on the presentation, but also we just created like a notebook. You can download it. If you have some questions, we have like a minute. Happy to answer some questions, but also if you have some questions, there's like a link tree, like you can just send us some questions if you have. Yeah, thanks a lot for listening. I think if we have like a minute, like if somebody has a question, we can, I think, use the mics over there. Well, thanks a lot, everyone.